Hello everyone, welcome back. Have you ever needed an AI to generate data in a specific reliable format? Not just a block of text, but clean structured JSON. Today we are building a cross-platform flashcard generator using C Sharp, Avalonia UI, and the Gemini API. We'll use AI to instantly create study cards for any topic, and the key is forcing the AI output into a perfect C Sharp object every time. So let's dive into the code. Here is the final app in action. I can simply enter a topic like the theory of relativity and click on the generate button. And within seconds, you will have a perfectly structured list of 5 flashcards ready to study. This is the power of structured AI generations. And to build this, we are going to use the MVVM model pattern. And this will keep our concerns neatly separated. Views are the XAML UI, models are the data, view models are the logic, and the services that will handle the external communications. And in our case, that will be the Gemini API. So without any further ado, let's get started. And for those who haven't subscribed to my channel, please do subscribe to my channel. It means a lot. It motivates me to create more such videos. Let's fire up Visual Studio and let's start by creating a new project. And let's select Avalonia.net MVVM app. If you do not find it your recent templates, please check out my other video. I'll leave a link in the description and also on the top over here, where I have explained how to install the Avalonia templates and how to create a new Avalonia project. For now, I will go with the recent templates, which is Avalonia.net MVVM app, and click on next. I will give this project a name called AI Flashcard Generator and click on next. The framework is .NET 8.0 and the MVVM toolkit that I'm using is Community Toolkit. And I'll click on create and let's wait for the project to load. So here you have the UI on the right hand side, and on the left hand side you have the XAML, and you can see this. Usually you do not have a designer for Avalonia, but if you install an extension, which I have talked in my previous video, you will get a designer like this. So I will go ahead and build this application first to see the designer in action. Okay, so here we have a designer. Now next let's create some of the folders for our services and converters. So let's start first by adding these folders to our solution. So let's add our first folder, which is called converters, and next we will have one more folder that will hold the services. So we have all the folders necessary. So let's start by making changes to the code and the UI. So first we will start with the data model, which is the flashcard.cs. So let's go ahead and add our first model within our models folder. So let's add a class over here and call it flashcard, and click on add. So I have already the piece of code that is responsible for making this application. So I will go ahead and paste this code, and I will explain you step by step on what the code actually means. Because if I keep typing all of the code, video will obviously become lengthy. So let me go ahead and paste in the code. So our data structure is straightforward. We define a flashcard class with a front and a back. The critical part here is that the JSON property names attribute, which tells the serializer how to map the JSON key names from the AI to our C# property names. Because we are using a structured generation, the AI returns an array of cards wrapped in a parent object with a key, which we have specified as cards, and the flashcard list class handles this top level structure, making this parsing clean and error free. So our flashcard class is ready now, and this wrapper will show the cards, and these are the properties that will be used to correctly deserialize the AI generated JSON. Next we will move on to creating our service, and this is the one that interacts with the AI using an API key and the URL, and this is the Gemini AI service. So let me create this class within our services folder. So if I go to solution and here I have created this folder. So let me go ahead and add this class and call it Gemini service and click on add. Now I will go ahead and paste in the code that is responsible for interacting with Gemini API. So let me go ahead and copy the code that I have and paste it over here. So this file handles the communication with the Gemini API, including setting up the request, defining the structured JSON schema, and processing the response. So let's first start by talking about the private constant variables. The API key is the constant string for storing the user's Gemini API key. Remember to provide your API key by going to the Gemini, not the Gemini, but the Google Studio, and creating your Gemini API key and providing it over here. Next, we have the API base URL, which is again a constant string holding the base URL for our Google Generative Language API. Next, we have the HTTP client, which initializes a singleton instance of HTTP client used to send all API requests. It is marked read only, and it ensures it is only set during initialization. Next, we have the method signature, which defines the core public method as it is async, and because it involves network input and output, and it returns a task that resolves to a list of flashcards, and it takes the user topic as an input, and this is the same topic that the user writes in the text and clicks on the generate button to generate those flashcards. So next is the structured schema definition that we will focus on, which is over here. And this is the most important part of the payload. It defines the exact JSON structure the model must return. It dictates that the output is an object containing a key named cards, and which is an array of objects, and each having front and back properties to the string. Next is the request payload construction over here, and this creates the object that will be serialized into JSON and sent to the API. It contains the user topic in its content property. Next is the generation configurations, and this sets critical generation parameters. Response meme type is set to application.json to enforce structured output, and response schema is included to provide the structure defined above. Next, we have the system instructions over here, and this provides the context to the model, instructing it to act as a subject matter expert and to generate 5 precise flashcards strictly adhering to the JSON schema. And then we have the content serialization, which serializes the C# payload object into a JSON string and wraps it into a string content object, setting the MIME type to application.json and for HTTP request handlers. Next, we send the request over here by making the call to the API and providing the API URL, API key, and the content. And this executes a asynchronous post request to the Gemini API endpoint. Next, we have the error check that throws an exception if the HTTP response status code indicates an error, which is example 400 or 500. Then we have the read response area, where we basically asynchronously read all the JSON body returned by the API into a C# string. Next, we have to extract the generated text, and the raw API response contains metadata. This complex JSON path navigates the response structure, and for example, the candidate of zero, content, parts, text, and so on. And to isolate and extract the pure JSON string from that model generated base, we use this structured schema. Then next we have finally the deserialization, and this takes the isolated JSON string, example text part, and converts it into our C# flashcard list object using the mappings defined in our flashcard CS file over here. And finally, we return the value that is extracted of flashcard object, and it includes a check to ensure that the result of the card array isn't null or empty, and returns an empty list if no cards were generated. So here we return an empty list, or we return the list that has in the cards. So now that we have finished with the Gemini service, let's focus on our view model. So next, let's create our view model. And to do that, let's go to the solution explorer, and under our view models, right now we have one view model already, which I will go ahead and delete. And also I will delete this view model base. And let's rebuild our application and see if there are any errors. So yes, we see a few errors. So let's see what those errors are. First thing is we have to rename this by first adding this view model to our view model. So I will copy this text over here. And since we deleted the view model, we will need a new view model. And I will go ahead and create a class and paste this text and just remove the window part. And because I want my view model to be called main view model, and click on add. After I do this, I will go ahead and paste the code that I have for my view model. And I will again, as I said, explain it step by step. So let me first paste in the code, save this, and now let's address the errors that we have. So first error is over here in our main window.xaml. So let me remove this window from here, and this should resolve the error that we have. So that is gone, and let's do the same to this data context. Save it and remove this text box, because the binding that was there was to the old view model. Now it should have resolved most of the errors. There are few more errors that we see over here, and that is in the app.xaml, and it's the same error that we see. I just have to rename it, and the error should be gone. And one last error is in, and that is also should be resolved. So no errors now. So let's start by going into the main view model, and I will explain you what this view model has to offer. So the main window is a central operational hub of the application. The job is to manage the app state, handle user interactions, and coordinate tasks between the user interface, the screen, and the Gemini API service. The foundation here is the main view model. Uses two main building blocks to work with the UI. First one is the view model base, and the second is the relay command. The view model base is the magic that allows the UI to automatically update when a C# property changes, like the number of cards, and it uses the iNotify property changed interface. And these are the implementation of the iNotify property change. And then we have the relay command, and this connects the generate button to the screen of to the C# method that runs the logic. So when we click on the button generate, the relay command basically relays the event to the right method in the view model. So that is where the relay command plays a crucial role. It also controls when the button is enabled or disabled by using these delegate methods, CanExecute and execute. And based on these, the button is enabled or disabled if the value in the text box is entered or not. Then we have the managing application state logics. So the view model holds all the crucial data points which are bound directly to the UI. The first one to highlight is the topic input, and this stores whatever the user has typed in the topic box. Where the text change, just whenever the text changes, it tells the generate button to check if it should become active or not. And this is handled over here, and this is the relay command that takes care of it. Then we have the is generating property, and this is a simple boolean flag. When true, it tells the UI to show a loading spinner, and change the button text to generating, and keep the button disabled to prevent duplicate API calls. Next, we have the flashcard itself, and this is an observable list that holds all the generated cards objects. When a new card is added to the list, the card displays on the screen updates automatically. Then we have the core working flow, which is the generate flashcard over here. And this method runs whenever the user clicks to the generate button and follows a simple robust structure. First, it sets up and locks. It sets is generating to true to lock the UI, clears any old cards, and resets any previous error messages. Next, it calls the service. It calls the Gemini service asynchronously and awaits to request the new flashcard based on the topic that the user has entered. Next is after this is done, whatever the user topic has been input and the call is made, it processes and cleans up the rest of the part. So first, if it is successful, it adds a new card to the flashcard list, and if an error occurs or network failure or anything occurs, it catches that error and updates the error message properly. Next, crucially, it finally blocks. It always sets is generating back to false and re-enables the button so that for the next input the button is ready to use. So this is simple. Now next we will bind all of these properties to the UI. So let's start by modifying the UI. So let's go to our main window.xaml and then start adding all of the UI elements, which is the interesting part. So let me go ahead and build this application first, just to rule out all the errors. Okay, so all our errors are gone. I will close this and we will start first by adding some of the window properties. So let me go ahead and paste it over here from the icon part. So here we have set an icon which comes in default. Then we have added a title, a width and height, and minimum width and height, transparency level, background transparent, system decoration to none. This means that there will be no minimize, maximize or close button, and a window startup location to center screen. Next, we will go ahead and add the data context, which is already over here, which is set to main view model. Next, we will add the Windows resources. So let me go ahead and paste in the resource, and we have forgot to create this boolean converter resource which we will need. So for now I will comment this out and I will tell you later when to work on this. So for now let's comment this. Sorry, I'll just take this and okay, so this is commented. Next we will move to the styles. So let's add some styles to our application. These are the default styles that will be applied to our controls. So here I have added windows.styles, and we have the first style that will be applied to our button, where we are setting the background, foreground, padding and so on for all the buttons, and the pointer over, so it will set a hover effect to our mouse pointer and it will update the background property. And this is the property for the disabled button, where the opacity will be updated to 0 0.6. And then we have a style for our list box on how the list box should appear. So after we have after we are done with the styles, let's add our main content which will be enclosed within a border. So I will go ahead and copy the code that I have and paste it right after our windows.styles. Paste the border. Let's close the border tag first. And here you can see we have this pointer pressed, which will add at the end. So I will go ahead and delete this, and this is a border which has a background and a corner radius, and within this border we will add all our elements. Let's start first with the grid. So let me add the grid here, and within, and also let's close the grid. And this is a grid that is that has these row definitions: auto, auto, auto and star. And within our grid, let me put the first header, and this is the header that will be displayed on our flashcard on the top. So it says AI flashcard creator, and it has a subtext, and these are the text blocks, and it is held within our stack panel. Next, we will slowly go ahead and add the input row, and this is the row where the user will add his topic that he wants a flashcard for. So here I have the input row, and it is within our grid of row of 1, and it is a text box, and we have set the binding to mode two-way, and the button is set next to it. I am not able to see the code, the UI controls generated on the builder over here. Let me go back to the code behind and see what the error is. So I think we need to assign the data context in our constructor. And if I do this and save this and go back to the window and rebuild, hopefully this should go away. Some reason this error does not go away, and I need to find why. Let me see if I what happens if I run the application. Maybe it's a bug in the Avalonia previewer. Okay, so the error is somewhere over here, and it says it is not able to find the bool to static string converter class, and this is my mistake over here. So I have added this converter class, and let's stop the application and talk about it. So here let me go to Solution Explorer, and within our converter let's add a class called bool to string converter. and add this over here and click on add. And now I have the code that I will paste here. And basically, this is a custom I value converter to convert a Boolean to one of the two strings based on a pipe separator parameter, false string or two string. So this is a value converter, and it is implementing the I value converter, convert and convert back. And basically, this is used to convert one value to another based on whatever value you have provided. So now that is out of the way, let me rebuild the application, and there shouldn't be any errors. One more thing that I have to do is to add this to our Windows resources, because it will not be able to find it when I run the application. So I will go ahead, and here on the top here you can see I have already added it, but I forgot to uncomment it. So I will go ahead and uncomment it, and also add this converter on the top as a namespace. So to do that, let me go ahead and copy this, and here after our here I have added this namespace. Now after I added this namespace, you can see the error is now gone, and it is now rebuilding, and it has populated the control which input takes the topic and the button that generates the flashcards. So we have one text box and a button, and here you can see it is using this converter to convert the value to using this bool to string converter class. So here this is done. Now I will soon explain you what this other methods are. So here next we have the loading indicator. So for that we need to add a stack panel, and within our stack panel we will have these loading cards. So after our grid, I will add this new section which will help us in showing a loading indicator and the error indicators. The first text box is to show the error, and the second is for the progress bar. Notice that we are binding the first text box to our topic input, which will go into our view model over here, and this will be bound to this topic input. Then we have the is generating, which will be bound to this button, and it will be enabled or disabled based on the relay command. And here you can see we have done the command binding. And next we have the error message, which will be bound to this error message over here, and it will be monitored by this property change event handler. And then finally we have a progress bar, which will be also bound to this is generating. Based on how long the API takes to generate, the progress bar will automatically update. Next we have the flashcard itself. So let me copy the whole flashcard section and paste it. So let me go and paste it over here. So here you can see the flashcard is by default loading of a temporary flashcard. So here you can see we had a default flashcard written. So front is the welcome to AI flashcard generator, and back is enter a topic, and so on. So here you can see on our window, here we have the same front and back data, and that is the default flashcard. And these are the data templates and item controllers for item templates for how the flashcard should look like. So this is basically WPF to display how the card should appear on the UI. So you can go ahead and study this and see how the UI updates based on the values updated on this XAML. So nothing fancy over here. So now our main window is loaded. All you have to do is replace your API key, and then see if all of this works perfectly fine or not. One thing that I have missed is to add this drag feature for our window, since we do not have the minimize, maximum, and the toolbox on the top. So here you remember we had our border which had this method. So let's go ahead and bring back that method that we had, which is the pointer pressed, which will be placed after our corner radius. And let me save this and go back to the main window.xaml and add that code for our pointer pressed. So this allows our borderless window to be dragged whenever the user presses and holds the header area or any other area, because we have now moved it to the border. So if you want a specific area for dragging, you can move this pointer pressed, for example, to the stack panel, and only this area of the stack panel will be able to drag. And if you move it to a border area, the whole window will be able to be dragged. Now I will rebuild this solution and run our application. And there you go, we have it, a clean cross-platform application that solves a real-world problem using a power of structured AI generation. By defining our JSON schema, we ensure predictability, reliability, and results every time. So for example, here if I type C# data structures and click on the generate. So if you see, if this text is empty, the button itself is empty. As soon as I type some data, the button is enabled, and this is due to the relay command. It tells whether the topic is filled or not, and based on that the button is enabled or disabled. And the button itself is mapped to an I command or a command to the view model, and as soon as I click this, the relay command triggers, and you can see the is generation taking action, where it waits for the results to load and the progress bar keeps updating. And here you can see our item template and the control templates are applied, so that we have a clean looking flashcard. And here you can see the front and back properties being updated, and we have 5 properties, and it 5 flashcards, which gives you a nice learning on what data structures are. So hope you all liked watching this video. All of this code for this project is linked in the description below. If you have learned something new from the C# Avalonia or using structured JSON output for the Gemini API, please hit the like button and subscribe for more deep dive developer content. You can also do the same coding, or you can use the same code to kind of create a WPF application and not a Avalonia application, because there it is not completely tied to the Avalonia objects or functionalities. This is mostly 90% of the code is plain old XAML and C Sharp. So you can make use of this in your WPF application. Please do try it out and let me know in the comments if it has successful and it has provided you enough information to create such WPF applications or not. To see you in the next video, where I will bring a new application and new concepts for WPF. So happy coding. Till then, bye bye.